All right, so prerequisites, algebra 2, 1-1 lines, and we'll spend another day tomorrow on slope and equations of lines and a little bit of that. But lines are a basic skill that we're expected to know if we're going to stand any chance at all in algebra 2. All right, first off, it's not a mother function. It's a graph x equals c, which we should know is a vertical line. So I call it a mom function. It's not a function, though, because it's vertical. And those of you who are doing this as a homework assignment, I can't put the xy axis on there, so I have to draw them. But we just pick a point on the x-axis and we draw ourselves a vertical line. Now, all I require out of students is to realize that this point is some constant with a y value of 0. The x-coordinate is c for constant, y value 0. Your domain and range. The domain can be written one of two ways. Interval notation, it would just be bracket with a c. Or, if you like set builder, all values of x such that x is equal to a constant. Range. Range is going to talk about your y values. This thing falls forever and it rises forever. So for my range, I would say negative infinity to infinity. Or if I like set builder, I could be all values of y such that y is an element of the real. So I ain't too bad. Next up is y equals c. This is going to be a horizontal line. This is a mom function. It's the mom function for all horizontal lines. And we just draw ourselves a horizontal line anywhere on the piece of paper. And on the y-axis, the x value is 0, so the coordinates there where we cross the y-axis are 0 and whatever the constant might be. Domain, it runs left and right forever. If you run left forever, you'll be at negative infinity. If you run right forever, you'll be at positive infinity. Remember, domain is your x values. X is running this way and that way. Your range is down and up. Notice we talk about the small negative values first, then the large positive values. Your range would also be, had a moment there. Your range is just that one y value, that constant. And the bracket is because there's a point there. Like that's labeled. I can touch that. I can't touch infinity. That's why I use parentheses. 3 is what the rest of this assignment's about. It's a mother function y equals a constant. Or y equals x, which is just your slanted line. It's the mom function for all slanted lines. Now it's going to cross the origin. It has a slope of rise 1, run 1, because there is an understood 1 in front of that x. Maybe you remember mx plus b. There's an understood 1 there. And it will also fall 1 and run left 1. We could make a table. You have to on your mother function quizzes. But there's y equals x. And its domain is that it runs left forever and it runs right forever. So its domain shall be from negative infinity to infinity. And it is also falling forever and rising forever. Now these are slanted lines. The domain and range of any slanted line is negative infinity to positive infinity unless it stops for some reason. Which we do piecewise functions. They stop because there's such thing as real world domain or domains that make sense. All right, there's the first 3. Here comes the next 3. More graphing. 1 through 6 are just graphing, and then the rest of it is writing equations, or manipulating equations, modifying them into equivalent things. All right, graph 1/2 x minus 3. Now this thing is written in the form y equals mx plus b. M is our slope, if you're that kid who just can't remember that. And the slope here is 1/2. It's not 1/2 x, it's just 1/2. B is your y-intercept. And I notice it's lining up with negative 3. It's a lineup process, so B is negative 3. So when I graph this thing, I'm going to start with my y-intercept. That's where we start. I start there, and it's from there that I apply the slope. I don't go to the origin and apply the slope. That's something I've seen a lot of kids do over the years. I don't know where it comes from. But I start here, and the slope is rise 1, run right 2. So I rise 1 and I run right 2. It only takes two dots or 2 points to form a line. It's a postulate in geometry. And there she is. All right, number 5, there's lots of ways of doing number 5. Number 5 was actually given to you in what we call vertex form. Most people don't talk about vertex form with lines because it's just weird. Like, why don't you just do y equals mx plus b with it? Do a little algebra. But you don't have to. It is in the form of a times x minus h plus k. Now, this guy right here is my slope. So my slope is equal to -2, technically over 1. H and k are kind of our center. Doesn't really apply with lines, which is why we don't usually teach lines like this, but it's kind of your center. And it's going to be, h is -3, not +3. It's always opposite. So h is -3, and k we keep the same, k is 5. All right, so when I draw this on the xy axis, I don't go, the original equation has a +3, I don't go right 3, I go left 3. And I do go up 5. Put me about right there. And now I can follow my slope. My slope is to fall 2 units and run right 1. So I'm going to fall 2, and I'm going to run right 1. And there's my 2 points. It's not hard. Number 6 is something that's given to us in standard form, and it talks about having both the x and y intercepts. Because if something is given to you in standard form, there's lots and lots of ways you can manipulate it. But the easiest thing to do is to find your x and y intercepts. So to find an x-intercept, we let y equal 0. So here's my y of -2y. I'm going to let that thing be a 0. 5x minus twice a 0 is 20. And you should remember doing this in 8th grade maths, possibly 7th, depending on the teacher you had, but definitely in Algebra 1. And anything times 0 is 0, so I have 5x equals 20, and this tells me that x is 4. So now I can start graphing. What I technically have here is I have an ordered pair, 4, 0. X was 4 when y was 0. So there's a point that I can plot. Now, to find the y-intercept, I let x be 0. So I see an x, I let it be 0, and I just write down the rest of the equation as is. And I now have -2y is 20, so y is 20 divided by -2, which is -10. Right down there. And again, postulate from geometry says a line can exist through any 2 points, or through any 2 points exists a line. It's been a while since I taught geometry, maybe 2015. So I may not have the wording of that postulate 100%. But there she is. Now, domain and range. It's a slanted line. The domain and range of any slanted line is -infinity to +infinity. Don't be the kid who doesn't figure that out. It falls forever and it rises forever. It runs left forever and it runs right forever. -infinity, +infinity, domain and range. All right, now we're into the fun part, the converting, looking or rewriting things equivalently. That's the fun part, making equivalent things out of what we have. Now, if you're a kid who doesn't like graphing, Algebra 2 is a graphing class. I mean, you can do algebra, but you're never going to be good at it until you actually get graphing, at least mathematics in general. All right, convert 3x minus 7 into standard form. And standard form is ax plus by equals a constant, where a is a positive integer. That might be the hard part, but a is a positive integer. Now, we have f of x listed, and f of x is just a fancy way of saying y, right? So, first line here, let's just say it's y equals 3x minus 7. By the way, don't be the kid who doesn't write. The kids who don't write don't do well in a math class. The kids say, I do it in my head. Well, you're failing. Try doing it a different way. Or you have a C. Try doing it on paper. Maybe you'll have a B or possibly an A. But what's a math teacher know, right? Now, in ax plus by equals c, we'll notice that this ax piece is all the way on the left, in front of the y. So we're going to have to shift this thing over here, and if we jump equality, we change our sign. You'll also notice they keep the constant on the right. Now, this thing's really close, except it says where a is a positive integer. So what we're going to do is we're just going to divide everything by -1. We're going to divide that negativity out. That'll give me 3x minus y equals 7. And it is now in the proper form. Underneath this, we have vertex form. And vertex form can have many, many answers. It can. I strongly encourage you to think about other ways you can do this problem. Do not sit there and blindly copy. Think. The worst thing a kid can do is not think. Society wants you to not think. Math class is trying to get you to think to some degree. All right? All right, so there's lots of things I can do. 3 will enter 7 one time with a remainder of 4, or it'll enter twice with a remainder of 1, or it will enter it 3 times with a remainder of -2. See, there's lots of things you can do. So let's think about this. We'll just make that f of x a y. We'll put a 3, and we'll introduce the x. Now, if I put a -2 here, I would have 3x minus 6. When I originally had 3x minus 7, that got all jumbled up there, didn't it? 3x minus 6. But remember, I originally had 3x minus 7. Now, what do I have to take away from 6 to get to -7, or take away from -6 to get to -7? I have to take away a 1. So there's an equivalent thing. I could have done other things. I didn't just have to do it that way. I could have maybe done like a +3. It'd be weird, but it wouldn't be wrong. What if I wrote +3? Well, that'd have 3x plus 9. But what I'm after is 3x minus 7. So in order for this to work, I would have to figure out what I take away from 9 to get to -7. And the answer to that is -16. There are lots of ways that you can do these things. You just pick one, okay? Pick one and go with it. All right, next up, number 8. We're given a vertex form, -2 times x minus 3 plus 7. We're supposed to convert it into slope-intercept form. That is really, really easy to do. To convert from vertex form to slope-intercept form, hit it with the distributive property and combine like terms. So if I distribute that -2, I would have -2x. Remember, a negative times a negative is a positive. So +6 and then +7. And surely we can add 6 and 7 together. I say that. There are kids who can't do it. It's really sad. But anyways, put 6 and 7 together, you should get 13. And that is slope-intercept form. That's mx plus b. All right, now, let's go from, well, there's a typo there, isn't it? That should not say vertex form. That should say standard form. Let's take that into standard form, which is that ax plus by equals c. And this one's like ridiculously easy. Standard form, we just move the 2x out in front of the y. And she is done. I did it with slope-intercept form, not with the original thing. Slope-intercept form is way easier to work with. All right, last one on the front of this page. Convert -5x plus 8y equals 12 into slope-intercept form. And there will be fractions on these. Not a big deal. Slope-intercept form is given to you somewhere. It's right there. Y equals mx plus b. You should have done a lot of this in your younger years. We're going to move the x's to the right. So my first line would be 8y equals positive 5x, because I jumped equality, plus 12. Now, it's not y equals mx plus b yet. It's getting there, but it's not there yet. So we're just going to divide that 8 out. And we're not going to go to a calculator and push decimals. There's no point in that. We have 5/8 of x plus 12 and 8 are both divisible by 4, 3/2. All right, and then we have vertex form. This one's going to be a little rougher. It's going to be quite a bit rougher. Because in vertex form, you have the number, the slope out front, followed by something. All right, so let's see here. I'm going to pull that 5/8 out. Y equals 5/8 of x. Okay, so this is not going to be pretty. Like, it's just not going to be pretty. I'm just going to put a -1 in here, and then I'm going to, on paper, think. I would have 5/8 of x minus 5/8. But no, the original equation had a 3/2, right? That's what the original equation had. The original equation had a 3/2. So I need to figure out how to get to positive 3/2. That's what I need to figure out, okay? So negative 5/8 plus what is 3/2? Okay, well, let's just do algebra. Let's move that over. The thing I'm missing is going to be 3/2 plus 5/8. Let's go old school, pretend we remember 5th grade math. 3/2, if we multiply that 2 by a 4, we'd have an 8 in the denominator, do the same thing at the top. 3 times 4 is 12. So it's 12/8 plus 5/8, which is 17/8. So I need to add 17/8 here to have the same equivalent equation. Now, if you picked a different number, you'll have to figure out what went differently. All right. Let's do the back side of this thing. There's only 2 problems on the back side. Oh, and I forgot to clear out the white stuff. Ah, let's see how this works. This could be an issue. It could be an issue. Yeah, because you don't see my hand over that, do you? Bummer. Okay, so let's move this out of the way. I've got points 3, 0, and 0, -5. So there's a graph of what I had, and I'm supposed to give the equation of this thing. I'm supposed to give the domain, the range, and 3 different forms of this thing. Domain, I'll abbreviate with a D, negative infinity to infinity, it's a slanted line. Range, I'll abbreviate with an R, negative infinity to infinity, it's a slanted line. Slope-intercept form, which is y equals mx plus b. All right, b is -5. That's easy. Your slope is your rise over your run. And we rise 5. And we run 3. So my slope here is 5/3. 5/3 x plus the -5, or just -5. All right, next form I have here that I want on this thing is standard form. So now I want standard form. Which is ax plus by equals a constant. Okay? And this one's not too hard. Now, the disclaimer here is that a is a positive integer. So the first move is easy. Move that 5/3 over. If you jump equality, change your sign. The next move is not. -5/3 is not a positive integer. The issue with the -5/3 x is the -5/3. The fact that it's negative and you're dividing by 3. Now the opposite of division is multiplication. And we should have learned a long, long time ago that a negative times a negative is positive. So we're going to triple every single thing in the equation and distribute a negative. And that's going to fix the issue we have. A negative times a negative is a positive, right? And a 3 divided by 3 is a 1. 5x. -3 times positive y, minus 3y. -3 times -5, positive 15. She is now in standard form. The next move is to do vertex form. This is going to be one of those that ain't much fun. But, you know, I'm supposed to challenge y'all. I'm not supposed to get a whole bunch of easy work. You're supposed to be challenged. So we're going to pull that 5/3. And then put an X in there. And you can just kind of do whatever you want here. Let's do -2. And if I put that back together, I'd have 5/3 of X minus 5 times 2, 10/3. But what I want is I want a -5. So I have to figure out what needs to happen to become -5. So -10/3 plus or minus something, it'll work itself out. That color doesn't show up oh, it was on my gold shirt. -10/3 plus or minus something is supposed to equal -5. I wish my pink marker was working, but it's not. Let me turn this down a little bit. That'll make things show up a little better for you. I'm going to add 10/3 to both sides. The question mark is a -5 plus 10/3. And I'm going to go old school. You know, I'm going to convert to fractions. -15/3, because that would be -5, plus 10/3 is my question mark. And that's going to give me something you can't see. -15 plus 10, -5/3. That's what I need right there. I need a -5/3. All right, 1 to go, kids. 1 to go. Hopefully you're learning something about basic math. If you don't believe this is basic math, you're basic. And you should fix that. Because by and large, that's a choice we make. It's a choice we make not to learn. Like, I get it. I get why kids don't want to learn it. I was a kid once too. All right, what's the next one look like here? We have a line, we got 2 points, we got -6, 0, and 1, 0. That should be changed to 0, 1, shouldn't it? I need to fix that. Even I get my X's and Y's backwards sometimes. Anyways, the goal here is to do some stuff, right? First thing up is domain and range. Domain, it's a slanted line, -infinity to infinity. Range, it's a slanted line, -infinity to infinity. Let's see if my pink marker is back by now. I had left the top off of it, dried out. Let's do slope-intercept form. Nope, it is not. The slope-intercept form is y equals mx plus b. This thing has a y-intercept of 1, so plus 1. Your slope is to rise 1 and then run 6. So 1/6 x. Y equals 1/6 x plus 1. Next up is going to be standard form, which is ax plus by equals a constant. So we'll work with this guy right here. We're going to take that 1/6, we're going to move it over. -1/6 of x plus y is 1. And we're going to fix the issue of being negative and dividing by 6, because we're supposed to be a whole positive integer. And we do that by doing opposites. The opposite of division is multiplication. And if I want to make a negative a positive, I multiply it by a negative. So I've distributed this. And the last one I didn't show how this worked. If you take a -6 and you multiply it by a -1/6, the 6's cancel. And a negative times a negative is a positive. So that just leaves me with 1x. And 1's are understood in mathematics. -6 times y is -6y. And -6 times 1 is -6. All right, that's STD form, standard form. What else are we missing? We're missing vertex form. And all these are fun, aren't they? I didn't try to make up anything nice on these. I didn't. Not a single one of them I made up to be nice. To write in vertex form, which is a times x minus h plus k, we're going to pull that sixth out. And I'm just going to make up a number. Let's say, I'm going to do something easy. Minus 3. And I'm going to think about what I have, okay? The reason I chose minus 3 will be apparent in a minute. If I was to distribute that 1/6, I would have 1/6 of x minus 3/6, which is 1/6 of x minus a half. I want plus a 1. So how do I go from negative 1/2 to becoming 1? I add 1.5. I add 3/2. And there she is, vertex form, for a random number that I picked. It's just how it is. And this would actually be a right 3, up 3/2, so it makes sense on the graph. And that is all I have for you. That took a lot longer than I thought it would.